Okay. So first, when we're graphing the absolute value of x, I'm just going to stick in a bunch of numbers. So maybe -4, -3, -2, -1, 0, 1, and 2. Okay. Absolute value takes that number, keeps it the same value, but just switches it to positive. So I should rewrite all these numbers, but in their positive form. Then I can plot those on my graph. Okay. I'm going to go up like this. And then I can take a straight edge of any form. I happen to have a ruler because I brought all my school stuff home. And we're going to draw a line through those points. Okay, so there's our absolute value of x. Okay, let's see. We're going to look at the domain and range of this. I'm going to zoom in. Okay, so Deborah, are you here? Henry? Henry, are you here? All right, Henry, I need you to respond to me. Rashani, are you here?
Yeah.
Hey, you're super quiet. If you could just like talk close to your computer. So I'm looking for the domain of this function. So how far left do I go and how far right do I go?
4.
Is there any stopping point when I go left?
No.
You're super quiet. Can you try speaking a little louder?
No, you don't stop.
Yeah, it does not stop. So what value am I going to put for my left-hand side of my domain? Rashani?
Is it 4?
No, so it passes -4 and it keeps going and it's going to keep going forever. What number represents forever?
You don't use the sign?
Yeah, so what's the symbol that we're going to use?
The infinity symbol.
Yeah, so I'm going from -infinity. And then how far to the right can I go?
Is it positive infinity?
Yeah, perfect. All right, and I'm going to use my round brackets because that's what I use with infinity. Thank you, Rashani. Jakeem, are you here? Marquez?
Ma'am?
All right, Marquez. So looking at the range, what's the lowest this function goes?
0.
Perfect. And is it included on this graph?
Yes, ma'am.
So we're going to use a square bracket. And then how far up can we go? Does it ever stop?
No, it keeps going.
Right. So what should I put here to indicate that it goes on forever?
If a positive infinity.
Perfect. And I use a round bracket with that. Excellent. Thank you very much, Marquez. Okay, and then my x-intercept is where it intersects the x-axis. So the x-axis is this axis right here. Okay. Regina, are you here?
Yes.
So what's my x-intercept going to be?
Not gonna lie, I don't know.
Okay, so it's where the intersects, it crosses the x-axis. The x-axis is this line right here. So at what point does this graph touch this line?
Is it the middle part or the
Yeah. Yeah, what value is this right here?
Is it a 1? Or is
No, 1 is up here.
So it's a 0.
Yeah, it's at 0, 0. Because it's at 0 on the x and 0 on the y.
Okay.
Perfect. Thank you. Okay, so make sure you have some sort of thing written down with that absolute value. And now we're going to look at the negative absolute value graph. I'm going to go through this very quickly. We have -4, -3, -2, -1, 0, 1, and 2. Because it has a negative outside the front, it's going to make every single one of these negative. -1, -2. And all that does is it flips the function upside down over the x-axis. So I'm going to have a function that goes down like this. Okay, so I'm going to grab my straight edge and draw my lines. Okay, so there's that side. And this side. Okay. So there's our negative absolute value function. And now we want to determine the domain and the range for that. Navre? Navre, are you there? Navre? Okay, Amar?
Yes.
So what's the domain for this? What's the farthest left and the farthest right it goes?
The minus 5.
So you said -5, but it's got an arrow. It's going to keep going even if there was like a -6 there.
It's 0.
Well, 0 is all the way over here, but it goes over here.
3.
Well, 3 is here, but it goes all the way over here. What's the farthest left it can go? Does it ever stop?
Yeah.
It does. Why is there an arrow here then?
I don't know.
So this arrow means that this goes on forever. What's the symbol that we use to show that it's going in this direction forever? What do we do up here?
We're positive.
No, we're looking at how far left we can go, so it should be negative. And what negative what symbol am I going to put there?
-5.
No, -5 is this value here, but look, there's a point at -6, so it goes further than -6. We're going to use this infinity symbol. Infinity indicates that it doesn't stop, it goes forever. Okay? If it's positive, it's moving to the right. If this is negative, it's moving to the left. Okay, so we're going from negative infinity to positive infinity here. Okay, does that make sense?
Yeah.
Okay, thank you, Amar.
Mhm.
Now for range, Katie, can you tell me the lowest point this function goes?
Negative infinity.
Good. We're going to use our round bracket for that. And what's the highest?
0.
Yeah, very good. And do I use the square or the round bracket for the 0?
The squared.
Good, because it's included on the function. All right, and then the x-intercept, Lamero, are you there?
Yes, I'm here.
What's the x-intercept going to be? Where does it cross the x-axis?
0.
Very good. And so I'm going to put a point at 0, 0. Okay, excellent. That was a little bit more of a struggle than it should have been. Okay, but these are the positive and negative absolute value functions, and these can be manipulated to create our applications. Okay, so we just wanted to have a little review to start. And on the inside of here, we're going to start with our applications. Okay. So first, it tells us, kind of like we did in our notes, we need to know our average and how much our function can vary. So this is stuff already written in our notes. Then we have a long explanation of a problem. The information that we need for number one, so for number one, the information that we need is about the temperature of the frying oil that they're cooking potatoes in. Okay, so it gives us a function here, and it says based on the information provided, what are the acceptable maximum and minimum temperatures of the oil used to fry potato chips? So it tells us that the equation that represents the highest and the lowest frying temperatures is the absolute value of T minus 183.55 is equal to 6.95. So this is the equation that we're going to use, okay? And that was given to us in the problem. Then it asks for our max and our min temperature values. To find this, we solve the absolute value equation for T. Just like we did 2 days ago or 2 class periods ago, we had to solve absolute value equations. So I'm going to take T minus 183.55. First, I'm going to set it equal to positive 6.95. This will give me my max value. And then my min value will be calculated by setting the inside in equal to the negative 6.95. Okay, so to find the max, I'm going to use this equation. To find the min, I would use this. And we're just solving this entire absolute value equation using the same methods we did before. So to solve these, I would add 183.55 to both sides, and I would do this for both equations, and we should get that T is equal to 190.5, and it tells us we're in degrees Celsius. And T is equal to 177 degrees Celsius. Okay, so we have our max temperature for frying and our min temperature for frying. What questions do you guys have about that problem? Okay. In number 2, we're talking about typical birth weight for a newborn. Okay, and it says it falls between 2.25 and 7.75. I feel like that's totally wrong because a 2¼ pound baby is so tiny. That's like probably a premature baby. And in part A, it says write an absolute value equation in one variable that can be solved for the greatest and least typical birth weights. So what we're trying to do is we're trying to come up with this function where we had the absolute value of x minus a number is equal to our variance, how much we can vary away from that average. So to find that number, we first have to find the average. Okay, and I need somebody to help me find that average. Ruby, are you there? Ruby?
Yeah.
Okay, so how do I find the average of two numbers? So I have it written here. Oops.
You add them and then you multiply.
What are you adding?
the minimum and the maximum.
And then what is going on right here? What is this 2 doing?
You divide it.